Okay, let's have a look at some sectors and segments exam questions. So we've got the figure AOB. So that has a sector of a circle. You've also got a triangle there. The angle AOB, let's just call it theta, it's sharper. So we've got to show what that angle is, or show what the cosine of that angle is. Let's think about cosine rule. So we use a squared. Let's just write that up there. What is cosine rule? It's a squared equals b squared plus c squared minus 2bc cos a. So if I had 2bc cos a, I always find it easier to remember it like this, equals b squared plus c squared minus a squared, and then you're left with cos a equals b squared plus c squared minus a squared over 2bc. Well, let's have a look at in this case. I'm saying cos of theta, I've just renamed it theta. Cos theta equals, you've got b squared and c squared. So if I were doing this, that's a, b, c. So we've got the 5 squared plus 5 squared minus 6 squared over 2 times b times c, 2 times 5 times 5. So you've got cos theta equals 25, add 25. You've got 25 add 25, which gives you 50, minus 36, gives you 14. Let's write that down. Over 2 times 5 times 5 in the denominator is 50, which is 7 over 25 as required. So just an application of cosine rule, showing the angle. Probably a bit long-winded there, but I just wanted you to see how you can rearrange the cosine rule. Some people do like to remember it in that form, but it's up to you, each to their own on this one. So find the angle AOB. So, okay, arc cos of 7 over 25, and we're going to do this in radians, is 1.287 radians. There we are. Now the sector of the area, we're going to find the area of the sector. So area of the sector, remember, is half r squared theta. So half times the radius squared, 5 squared, times theta. So times 1.287. So let's have a look there. So we stick that into your calculator and you get 16.087 or 16.1 to 3 significant figures. Always 3 significant figures if they don't specify. Well, let's have a look. I'm going to do D up here. Apologise. So we've got this shaded area. We want to work out this shaded area here. Well, that's going to be the area of that's going to be the sector minus the triangle. So the area of the triangle is half AB sine C. Remember the half times 5 times 5 sine theta, using a sine rule for the area of a triangle. So that will give you the area of that triangle in the calculator. Gives you 12. Well, it's pretty close to 12 anyway. On the calculator, it comes up with 11.9999, so I'm going to call it 12 here. So that segment, this is the segment. Remember, the segment is going to be the sector minus the triangle. So the segment is going to equal our answer from before. So we've got, what, 16? Well, 16.1 minus 12 is going to equal 4.1. 4.1 meters squared. I should really have put meters squared here as well. Okay, there we go. Let's hope we're happy with that. Let's have a look at the mark scheme for this. So there we are. We've got use of the cosine rule, gives you a method mark. And then the final answer, there's just possible use of another method there, using a double angle formula, but easier just to stick the cosine rule in. There's the angle, finding the angle, that's just calculator work really. C, finding the sector, just the formula, using the formula, half r squared theta. And here we're using the triangle, area of the triangle. You're then using your sector from the last question, take away the triangle to get 4.1. Okay, here's another question. So let's look at part A. We're going to use arc length equals r theta. The arc length is 28. You can clearly see that. We've got radius of 20 times theta. So theta's 28 over 20, or 28 over 20 is 1.4 as required. What's the area of the sector? So the area is half r squared theta. So just show you working clearly to the examiner. 20 squared times 1.4, and you should get 280 centimeters squared in your calculator. There you go. Let's this up a bit. Here we are. We've got another problem. They've made it slightly trickier here. So you've got the same triangle, but this has been shortened. So you've got 15 and you've got 20 there. So you've made a little triangle there. So the length of OD is 15. So that's obviously got to be 5 there. So just to refer back to our previous example, find the area of the shaded region. Well, the area of the triangle, so you've got the triangle area. I'm just going to use that notation. We've got half times AB, 15 times 20 times sine of 1.4. So remember, half AB sine C, that very useful area of a triangle formula. So that should give you, to one decimal place, 147.8. So what do? We want the shaded area. Shaded area is going to equal our answer from before, which was 280. 280 minus 147.8. Just think back to the answer from before. And we've got 132 centimetres squared. If I'm just going to round that to 3 significant figures. There you go. So just the last job really is to use the cosine rule to calculate the length BD. So BD squared equals, so BD squared equals 15 squared plus 20 squared, A squared plus B squared, remember, minus 2 lots of 15 times 20 times the cos 1.4. You put that all in, you square root it. I think you should be okay with that from GCSE. 22.9 centimetres. Again, 2, 3 significant figures. So, very good examples actually there. Hopefully it's clear. We've found the area of the sector previously. Here, found the area of the whole thing. We've then used sine area rule to find this triangle, so we can find the shaded area. Subtraction. Common type of question there. Then let's look at what they're asking for in the mark scheme. So the first one, if we think back, we're just showing theta's 1.4 arc length. Area of the sector formula, just applying that. C, we find the area of the triangle, we subtract sector, take away triangle. It's a common theme that in these questions. And then a bit of cosine rule, which you'll often find in these type of questions. So this is an old AQA question, I think, and I think it's quite nice to show the skills. Thank you.